this is gonna suck. Oh, it's so fucking... Jesus. It's the red knob. Oh. There we go. Is it gonna fit? You can't even see it. What was the point of that? Oof. So it's the twin. The red knob twin. I'm just gonna push my hernia back in. So this one, various issues. Last one of these I did was about 800 bucks. Had a lot of bad mods done to it. A lot of just really shoddy work. So a lot of the labour was reversing that, but it also needed a full recap. Lots of drifted components, lots of dry solder joints, and new set of valves and all of that. So yeah, I'm not sure this is what they refer to when they call it the evil twin. I have to brush up on my history there. I thought the evil twin was the master volume blackface thing with the skirted knobs. I could be wrong, but yeah, the last one, when we finished it, sounded amazing, and it certainly didn't beforehand. So I think they're worth doing, and you can make them good. And was it Johnny Greenwood from Radiohead had one, and everyone wants them for that now, because all the 90s kids are starting to actually have some money, so they're buying the amps that their heroes used to use. So we'll crack it open, we'll have a look, and we'll try and come up with some kind of quote to provide the customer before we go ahead, because I dare say at this age she's probably going to need a little bit of work. The twin. Say hello to the red knob. Not just me, the amp. So the first thing I notice, get my little pointery McPointer face. This resistor here is breaking down. These two form a resistive divider to drop the voltage down for the preamp nodes. They overheat and they lose the ceramic infill heats up and falls out. A bit of vibration in with the mix as well. Last time I replaced them with, one was a 2.7, one was a 30k, yep, 2.7. I replaced them with these little buggers. Pretty low mass, high quality resistors. And as for the 30k, I don't think I had any spare. Oh yeah, no, I got some spares of them too. Sweet, from the last one of these I did. So there's a 10 watt, nice quality ohmite 30k as well. And that amp's still going strong after a year and a bit. So someone has been in there. Let's just check before we go fingering the amp. Let's just check that there's no residual voltage. So let's set our multimeter to volts and just check out, well, let's check big caps first. 0 volts. 0 volts. Now, if you want to be 100% sure, put the leads over the actual terminals of the cap. So we're on DC volts. Check the actual caps. 0 volts, 0 volts, 0 volts, 0 volts, 0 volts, dodgy, shittily installed cap, 0 volts. Everything's 0, we're fine. And it's not plugged in. Just double check that. When I'm inspecting an amp like this, I'll roll up its cable just to keep it neat and just sit it next to the amp where it's visible, so you know that it's not plugged in. The more complacent you get about it, the more assumptions you make, you end up getting in trouble. well, the second thing I noticed after the resistors is this cap installation. So yes, axial caps one day will be probably impossible to get, or extremely expensive and specialized, but at the moment we're not at that point yet. And this guy has used a photo flash capacitor, which looks to me, I've never heard a capacitor being sold as a photo flash capacitor, so I dare say this idiot's probably pulled it from a disposable camera. Joy! So that's the most hacky thing I can find in here. Everything else looks pretty stock, and I don't think that's a showstopper. It's very, very poorly done. Probably one of the worst. So I think we can take a few measurements with the amp turned off and just determine possibly if there are any other showstoppers, like the output transformer, etc., and just go over the thing in the process, look for cracked solder joints. Most of them happen in this area. Sorry, zoom out. Most of them happen in this area because of the heat generated by these resistors, and it affects the solder joints underneath. That board is removable. It's not, everyone whinges about these amps, but they're not that bad to work on. Honestly, Mesa Boogie's are way worse, and they're worth 10 times as much. So these IC caps retread, I think this was before they sourced that absolute shit bunch, and look, I'd be quoting for, no, there is some leakage on these ones too. I'll be quoting for a full recap of these anyway as a resto of this amp, because I can't trust the old caps with the job that I've done, because if they blow up and it comes back, well, it's my fault because I repaired it within 12 months, or, well, it's supposed to be 3 months the warranty, but in the customer's mind it can be 3 years and they still want it repaired for free. So I'd rather not deal with it. I kind of want to go all out or go home, you know, go hard or go home. Is that it? I don't know, whatever. But yeah, this one's not too bad an example. It's reasonably neat and tidy. No massive hackage done, and this guy, by virtue of his laziness, he's probably done less damage than if he tried to do it properly. Looking at the quality of work up here, he's just snipped leads off of the pre-existing capacitor. Well, we can see one capacitor's failed, so the others will shortly follow, right? So if he pulled the board and tried to do this properly, he probably would have done damage to the bottom of the circuit board, but because he hasn't touched the factory solder joints underneath, the circuit board, aside from this area, is probably in reasonably good condition. We can have a quick look at that though, because all the wires come off this side, so we can flip it up and have a quick look just by undoing the 4 screws. Maybe we've got to snip a cable tie or two, but you know, if that's the most we've got to do, that's pretty good. And as for crappy cap installation and 6, oh no, I just said it. I've seen it all, man. I've seen a section of extension lead, like appliance, like extension lead, like grey wire like that. It was snipped off, probably about a foot long. It tack soldered to the circuit board on one end, and then it tack soldered to a cap that was just floating around in the chassis on the other end. That was probably the best one I've seen yet, and of course that was on a Mesa as well, dual caliber 20. He paid the Mesa tax big time on that one. Alright, so you can see all of the burn damage done to that area. So essentially those components are just nowhere near far enough off the circuit board to allow adequate airflow, and they're kind of not the best way of doing it anyway. You don't need a resistive divider to power the preamp circuit, you just need to consider the circuit as the bottom resistor of the divider, and then have a suitable resistor at the top of it, instead of having to stiffify the supply with high power resistors. You can just allow it to flex a little bit, and just don't power the thing up with no valves in it, because you'll overrate the electrolytic capacitors. But that's how the majority of amp manufacturers make it. They have droppers in a string, like a ladder, going down to each preamp node, and as the less voltage is required, you just have more droppers, and you change their value. Near enough's good enough. It's a valve amp, you know. So yeah, they're usually round values, like 100k, 10k, or 10k, 22k, 33k. They're sort of pretty standardized values. And then you consider that the top, when you see a dropper resistor, consider that the top resistor of a resistive divider, and the bottom resistor of the resistive divider is just the circuit that you're powering. That has the side effect that if there is no load on the bottom, then that each node will sit at the full B+. So say you've got 350 volt, what are these at? They're all 500 anyway, so it's not the end of the world. But say you've got, in your first preamp nodes, you've got 350 volt capacitors, you'd be overrunning them a fair bit. If you took the valves out, then it'd be no load, so it'd be floating at 480 or whatever the B+ is, and that could damage the caps. So anyway, where was I? I think we can take a few measurements on this. I reckon I could throw a dart at it. I reckon that will probably power up. I might just change out that one cap and just have another look at the job sheet and see what the description was of the fault. And we might gingerly fire the thing up and see what's going on, and just come up with a quote. In the meantime, I'll just check the screen grids because they're carbon comps. 466, that's good. 482 within tolerance. 476. 469. So they're all within spec. I'll probably replace them anyway because they're carbon comp. It's not a great screen grid resistor. They're only 2 watters. Probably put 5 watters back in there. And full recap. I think if we charge enough labour to cover all of that, and just add a little margin on top, say another 20%, we should be able to cover any preamp valves or weird noise or anything that's happening. And I'll just check the speakers and all of that as well as usual, and we'll go from there. But yeah, not a horror show, so that's good. Alright, so before we go powering this thing up, we're going to check the fuse ratings and their continuity. There's a ton of fuses on this one, and then it's mains fuse, which is the only accessible one from the rear. Let's start with that. Just checking the ratings. That one looks intact. There's some kind of weird crap on the end of it. Looks like wet sand. It's all come from this resistor, it looks like. So the cementy type stuff that they used on the end of that has sort of started to degrade, probably from heat. And someone's probably sprayed some WD-40 or something in the fuse holder, so now it's made it all stick together. So we'll clean all that up. But the fuse looks intact. It is 4 amps, which is what it says on the back, and it is intact. Pop that one back in for now. Now this is interesting. It's a good idea too. They've got 2 parallel fuses. I'll just show you in the schematic. So they've got 2 parallel, series fuses. So this one here, F301, is accessible from the back. That's showing the American currents and voltages. Down here, 250, 8 ohm. 8 amp. So this is the one we're looking at. So 301 is the accessible one at the back, 4 amp, time delay, 250 volt. This is the one on the circuit board in here. That is 5 amp, so just 1 amp more. That's just so if someone thinks they're a genius and wraps this one with foil or puts a 20 amp fuse in there, then there's a internal backup that's a bit harder to get to for the average monkey. So yeah, that's a good idea. It's a bit of a backup thing. So I'll just have a quick look at the schematic while we're there. F306 10 amp, so that's the heaters. F306 is down there. What rating have we got on that? There's a loose end on that fuse, so we'll replace that fuse. It's a 10 amp though, and for now it's intact, but the end cap's spinning free. It's not glued to the glass any longer. Just double check the continuity of that. Now that's going to show continuity regardless, because it's across a very small DC resistance on the, but no, the fuse is intact on the windings. Looks like a bit of burning in that fuse holder, as is often the case on heater fuse holders. It's not a good idea to have them. It's just too much current, with the exception of maybe an automotive blade fuse holder. These little circuit board things just aren't designed to deal with that kind of current, so they often get hot and then they oxidize and then they don't conduct very well. Just give that fuse a bit of a clean. I just want to get this thing up and running and just at least identify the fault before we go crazy restoring it. So the report is the lights are on, no sound. So moving on, fuse 305, which looks to be a bias fuse. 305 brown 350 milliamp. It's got some kind of residue on it too. Someone's sprayed something on these contacts. Now, when using a contact cleaner on something like this, you're supposed to use one that doesn't leave a residue. People just use WD-40 and stuff. Basically, WD-40 is not really good for anything. And if you're going to use a contact cleaner, use one without a lubricant. So there's ones that have lubricants that are meant for moving parts like switches and potentiometers, and then there's ones that leave no residue that are meant for just cleaning contacts like plugs, sockets, multi-pin connectors, that kind of thing. And you should never use one that has a lubricant in that situation. Likewise for fuse holders. So all these fuses just have a strange residue on them, so let's just clean that off. You see all the crap on the cotton bud there, that's just from these fuse holders. Alrighty, so I've got some meters set up. This one's for probing, ground attached to the chassis. These two are monitoring the voltage drop across each side of the output transformer just to see if anything's massively out of balance. I've got the power meter on the wall as usual, about to fire it up on the variac, just check that there's no shorts before we go too crazy. I'm drawing 6 watts, which is the idling current of the transformer itself. Bringing it up, going up to about 60 volts, 10 watts, 14 watts, 15, 22 watts, 25, it's dropping down as the heaters warm up. So there's no catastrophic shorts there. Go up to about 110, 39, 37, 36, 35 watts. starting to see some voltage drop. Very little, but some, which means they're starting to conduct. Let's give it some signal. And we've got some hum. Quite a bit of hum. Quite a bit of hum. So the report was no signal at all. There is signal. Hear that? It's being modulated by the hum. That's 100 Hertz hum. Let's just double check that. Flick it over to frequency reading. Voltage AC, frequency on the tip. 100 Hertz. Hurts so good. So that's a lack of filtering. We'll look at how much ripples on the B+. Sorry, let's switch that away from frequency again, go back to volts, AC, and we've got 32 volts AC on B+, and at the midpoint of the two we've got 32 volts. So we've got a failed filter node, failed filter capacitors. We are getting signal, but it's heavily modulated by that hum. So, buggered capacitors. That's problem number one. Let's check the filtering on the other nodes. Not much on that node, that's one of the preamps. Quite a bit on that one, that's those shitty caps. Quite a bit on that node, probably because that's the first one after the main filter cap. So we're looking at least a filter, a recap, and the customer reported that these all the valves were replaced at the last service, which was less than a year ago. So all valves replaced, he said. The only valves which aren't original by the looks of it are the output valves, so all of the preamps are still original. So I'll let him know that, and when we get the amp into a condition where we can sort of, you know, fine tune some stuff and look for any other secondary issues, we'll see if all those preamp valves are okay. But I might factor in one or two just in the price, just so he doesn't get a shock when he gets the bill and there's 2 or 3 preamp valves on there as well, if they turn out to be microphonic or causing noise or something like that. But yeah, basically with this we need to give it a clean up, recap, change these shitty resistors, and then go from there.